So as I said, we want to make sure that we utilize the proper techniques to appropriately assess a single case. And it's complicated, of course, by the fact that there's only one participant or situation that we're observing. So we have to gather a large amount of data from a relatively, or in some cases, very, very small sample. So utilizing these techniques, we want to go for more of a graphical display of the change. So for example, if we look on the left, what we're looking for in the baseline phase is we want to see how the data is trending, right? So if you look at how the very top left graph there, we see that there is a kind of up and down, but more or less a flat trend. If we look at the one below it, you see, once again, some fluctuation, but an upward trend. And then finally, on the very bottom one there, we see a fairly continuous or slightly fluctuating line, but in this case, a downward trend. We want to make sure that we understand that prior to the treatment, prior to the observation, that there is some sort of stability of the baseline. If we look at the middle graph, the top middle graph there, that baseline is terrible because it's all over the place, ranging all the way from almost 0 all the way up to 100. So that's not a good baseline. That's not going to be a good place to start. The one below is going to be much better. As I said, more fluctuation, or some fluctuation, but much more flat. What we're going to see in the coming slides is the graph on the right here, where we alternate between a baseline and a treatment phase that allows us to establish causation and see how the individual trends with regard to what's going on in their treatment. So we're going to look at three main designs. We're going to look at ABAB, multiple baseline, and changing criterion. And with these, it's going to allow us to not only see where the participant is, but how they change in response to treatment and what the long-term effects of treatment are. And I could not find anything on Google Images that represents ABAB, so for that reason, there's ABBA, the Swedish band from the 70s. So hopefully that'll help you remember it. ABAB, let's walk through this one. So in this one, this design involves a baseline phase, which is represented by an A, right? I know it's counterintuitive. You would think baseline should start with B. Yes, I get that, but I apologize. I didn't invent this. I'm just the messenger. Baseline phase is A, treatment phase is B, and what they are is they're staggered repeatedly. So if you look at the graph down there at the bottom, right, we see the baseline phase. And during the baseline phase, the participant is not receiving treatment. They're simply just being measured, right? And we notice some fluctuation, not a great deal of fluctuation, but a pretty flat trend, right? It's doing the same thing pretty continuously for the first week or so. And then we notice once the intervention or treatment is introduced, they start trending upwards almost immediately, right? So in this case, they seem to be getting better during the treatment phase. What this design involves is after that, after the treatment phase indicates the trend upwards, you take the treatment away so that there is a return to baseline. So you've actually got a second baseline phase. So it's AB, AB, right? So you're returning to the baseline phase, and notice there's a quick drop off and then it returns to almost exactly the same level as the original baseline. Once again, for a second time, you introduce the treatment, and once again, we see the same sort of pattern of an upward trend almost immediately after the treatment's reintroduced. This back and forth allows you to establish the causality of the treatment and establish whether or not the participant's getting better because of the treatment itself or because of a placebo effect or maybe even other factors. This design can involve many different types of treatment, right? So you can have treatment phase 1, 2, and 3, and they can all be different. But as I said before, the real goal of this, the benefit of this, is it allows to establish a causal role of treatment, right? You can also repeat this forever. Basically, it can be AB, 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 AB as many times as you want, right? It's only AB, AB in the name, but it actually can be AB, AB forever, right? What we want to make sure we see is stability in the behavior during the treatment, right? Or excuse me, scratch that, during the baseline. Whenever they're in baseline phase, they need to have stability. And what we see is when you take away the treatment, we should see a relative return to the baseline. So in the absence of the treatment, they should go back to the way they were, more or less. However, the big consideration in this is if the treatment is being successful and you take it away to test the causality, you've now deliberately made somebody worse, which is dangerous for a variety of reasons. Particularly, you're endangering the potential of their health, their lives, and there's also the potential for litigation because you've now deliberately made them worse to see if there's a causal effect of the treatment. Multiple baseline design, so new design now, multiple baseline allows us to not have to withdraw the treatment, right? And the name is just as it sounds. So if you'll notice, we've got these 4 clients here, right? And what we're seeing is there is a long pre-treatment baseline phase, right? And each one for 1, 2, 3, and 4, it gets progressively longer. So participant 1, just a short one there, but participant 4, quite a long pre-treatment baseline phase. And what it allows us to do is establish what they look like prior to the treatment. You test during the treatment, and then in all of these cases too, there is a post-treatment follow-up. So there's no need to take anything away to establish causation. You can just re-examine. Notice too the exceptionally stable baselines in each of these. That's what we want to see. There can be slight fluctuations. So you see in 2 and 3, there's a little bit of fluctuation there. That doesn't matter. Otherwise, it's a very, very stable baseline. And as the slide says, the real benefit is that you don't actually have to reverse it. You're not taking anything away once it's successful. As it indicates, obviously, there's going to be a minimum number of 2 baseline assessments. And what we see is actually, it says independence. It should have a question mark at the end of that second bullet point. We actually begin to see an interdependence of baselines. That even though there's separate assessments, they are going to connect to each other. And I guess to some degree overlap, right? And the more baselines we have, the more we expect to see some overlap, right? So that's just something to keep in mind as you go to develop this is, at some point the baseline assessment becomes not an assessment of the person, but an assessment of the assessment, as it were, right? The third, this is actually my favorite type here. So we've got changing criterion design. It's going to say it on the next slide, but let me start with the fact that this design is utilized for a terminal response. Okay, and what that basically means is at the end of this treatment, the person should no longer display the behavior, right? So this is not good for dieting, for example. So people say, oh, this is like a diet. No, because after the end of the diet, you're still going to weigh something, right? You're not going to weigh 0. You might have lost weight, but you're still going to weigh something. This would be better, for example, if you wanted to stop smoking or wanted to stop drinking caffeine, okay? In this case, you're actually reducing the amount based on the phase, but eventually the expectation is you will no longer smoke or you will no longer drink caffeine. And once again, we've got a baseline phase, right? And I'll use caffeine as the example in this PowerPoint. But what you do is you actually do baby steps. So during the first week, you have less caffeine. During the second week, less than that. Third week, so on and so forth. And the idea is you're taking minor steps to kind of wean your way off of caffeine. And if you've ever tried to just give up caffeine cold turkey, you understand there's actually withdrawal symptoms. Stomach aches, headaches, lethargy, irritability rather, all sorts. Very much like if you were to give up a hard drug like heroin or cocaine or something like that. It's there's some serious physiological and psychological effects. So this allows you to kind of get rid of it slowly in a way that's not going to produce those effects. So as I said, terminal response in that first bullet point there, we want to make sure that that is in our notes as a goal, as the main goal of this type of treatment. The second idea is that it's very compatible with everyday life, right? So, with something like smoking, for many people, especially if they smoke for a long time, giving up altogether would be very difficult. Caffeine is the same way. If you're used to a cup of coffee every morning and suddenly now you're not allowed to have one, that's very difficult. But if you have smaller and smaller cups, less frequently and less frequently, that's a much easier way to go about getting rid of it. The downside is because it takes longer, because you're doing, weeks of weaning, you might have a particularly difficult week where you're like, oh man, I really need to do a cigarette this week, or a really difficult morning where you're like, I have to have a cup of coffee. And those can, of course, create these extraneous or confound variables that can interfere with the treatment. A good way to think of this, too, is nicotine patches. So when people try and stop smoking, they'll wear a large nicotine patch when they first start, a slightly smaller one when they go for a little while, and then an even smaller one afterwards. And usually there's a 3-patch sort of sequence that they can follow as they go to wean themselves off of the nicotine. So when we evaluate the data, I'm going to throw these 4 points on here, but they'll make more sense when you look at the pictures. Essentially, we're going to do visual inspection for data analysis, right? Data evaluation. And we're going to look for these 4 things: change in means, change in level, change in slope, and change latency of change. And let me show you the pictures. I don't think the words here aren't going to make much sense at the moment, but I think the pictures make a lot more. So let me show you those. So this first one here, the top one there, change in mean. If you notice that dotted line, that segmented line there, that is the mean. And what we're looking for is, does the mean change from baseline to intervention phase and back and forth, right? So notice it goes from its baseline, it goes up, baseline 2 goes back down, second treatment phase, it goes back up, right? That's what we're looking for. How does the mean fluctuate in the graph? The change in level, what we're seeing, don't confuse change in mean and change in level. If you look at where the arrows are, there's 3 arrows in this bottom graph here. And what we're seeing, we're not looking so much for the change in mean, we're looking to see how much it jumps from a baseline to an intervention. Notice how, especially from baseline 1 to intervention 1, there's a massive jump, right? And then once again, from intervention 1 to baseline 2, it drops like a rock. And then a third time, baseline 2 up to intervention 2, there's a massive jump. This is a change in level, right? So it's literally just jumping up and down depending on whether or not they're being treated or just going to a non-treatment phase. Change in slope is exactly as it sounds. If we look at baseline 1, we're seeing a flat line, basically, a trend in a flat way. When we look at intervention 1, we see an upward trend. Baseline 2, we see a stark downward trend. And then in treatment phase 2, we see a stark upward trend, right? So what we're looking for is how is it trending from phase to phase, and we look to see if there's a change in that trend across each phase. Latency is actually my favorite. I have favorites of everything. Latency is my favorite because this is kind of what you would expect if you were to go on antibiotics, for example. Or, a great one is if you were to go on, for example, like Zoloft, right? If any of you are on Zoloft, your doctor probably told you, oh, you're going to have to wait probably 2 or 3 weeks before you start to feel any difference, right? This is latency. So if we look at that top graph, right? In the top graph, there is 0 latency. Basically, as soon as the treatment starts, the person begins to feel better, right? However, in the case of Zoloft and most psychotropic drugs, and then also like antibiotics, you're going to start taking the intervention or the treatment for a while before there is any noticeable change or measurable change. That is latency. Okay? And I think latency is important because it gives us, we need to be aware of it when we're examining the treatments, but then also consider what that period looks like and how long and all sorts of factors. But latency is an important aspect of it. So some things to think about as we wrap this up. Let me throw all these on here. I've got a couple of case studies that I've mentioned as examples. Phineas Gage, of course, the use of atomic bomb in the bottom left there. And then Jeannie, I mentioned her in a previous lecture, but this is Jeannie Wiley was her last name, is her last name. She's still alive. And then she was from the book that I mentioned, Jeannie, A Scientific Tragedy. She is a very important case study. I don't want to go into it because it makes me very sad, but I would really invite you to explore it further if you're unfamiliar with her case. As I said, read the book, Jeannie, A Scientific Tragedy by Russ Reimer. So what are the risks of the patient? Make sure that is the #1 priority. What are the risks? When you're studying something, you have to study it with the person or people who are affected by it as your central concern. So Jeannie, for example, Phineas Gage, the people of Hiroshima and Nagasaki. American history remembers President Truman as a hero for the one who ended World War II. He also deliberately killed 250,000 Japanese civilians. So I don't know that I would use the word hero, right? Those people were innocents that were essentially forfeit to stop the war, right? So how rare is the case? When it comes to case studies, it should be very rare. Can you collect several singles? I mentioned this in the early part of the lecture. There might be a situation where there are multiple instances that are rare and unique, and you can start to study them collectively. Will the results be generalizable? No, that's not the point of case studies. What's the best design? That's going to vary depending on what you're trying to study, how long you've got, the nature of the participant, right? Benefits should be exploration of a rare topic. Drawbacks should only be incurred by the researcher, not the client, not the participant. Okay? How will I analyze it? This is important because as we talked about with the graphs, we want to make sure we're aware of what we're going to expect to see and how we intend to see it. Okay? And then who's paying for it? In this case, I'm not talking about monetary costs. I'm talking about cost to the participant. As I said, we want to keep the cost to the participants as close to zero when we're studying these case studies, because often these people are case studies not for positive reasons, but for very negative reasons altogether.